Welcome to all to class number 100. I told in the earlier class, in the class number 100, I am going for some special or rather very beautiful or what you can call is some extra information which you require. This, I written here, real concept of shear force at the point of concentrated point load, or see here, if the point load is here, what is the shear force at this point? If you remember, we are telling earlier all, just to left, just to right. Okay, that is not wrong, but more clarity and information and deep inside concepts I will explain here. Now, one note, I written class means I will tell now, that is very important. Entire class you have to go through without skipping anything if you really want to understand. And secondly, this class is meant only for those who are interested in gaining more and more knowledge about the variation or about SFD and BMD. People who just want to pass in examination or just to manage some diagram, for them this class is not ideal. Because first of all, their preference is what? Just how to solve the problem or just briefly to know about SFBM. No. This is meant for the people who want to gain higher knowledge or people who got curiosity. So many things which they come across in structural engineering field where they don't get the answer. This is the class which will give the answer. Later in future, I will upload more and more such classes, not only for SFD&BMD, but for other chapters of strength of materials or structural analysis or RCC steel, depending later on availability of time in between. Okay, now I will write here first, see. Consider a simply supported beam of span 10 meter. Start from here. Subjected to a concentrated load or point load. Usually we call point load. At 20 kilonewton load, some random load at 4 meter from left end. See, beam of span 10 meter, I will call beam AB, 20 kN at 4 meter from here. This point I will call C for future reference, point load point C. Question is, we have to draw SFD and BMD with full clarification and all the concept to cover. For your information, this question was solved long back. See, in the starting, I told Roman 1, Roman 2, this is Roman 3 I think. First we solved span L, load W at A or B, then some numerical are given. So this is numerical. Same question, not 10 meter, I don't remember, I have not seen there, some other length. Not 20 kN and 4 meter, some other values. We solved systematically. If you remember, at that time, I did option 1 and option 2 both. Option 1 is systematic by taking section XX. Option 2 is easy approach. Now, even for this question also, I am starting from there. That is actually, I will tell after some time that up to here is repetition. You should not tell repetition. Why? Let everything come in compact form in one class for understanding purpose. So, first I will go for, see, let us first draw SFD&BMD in the same way as universally done. That is what everybody will do, universally done. And for that matter, I written here, or the same way as done in this course so far. Close the bracket. In this course so far, earlier, how I used to tell? Means the ultra special concept I have not told earlier. I kept pending. So without telling that concept, I used to tell, I used to solve questions when point loads are there in the same way as universally done. Okay, first you finish that one. Little fast I will go because already known for you, but go through. Calculation of support reaction, waste of time explaining. Take moment about A, minus VB into 10 plus 20 into 4 equals 0, you get VB, sigma V0, you get VA. Now, option 1, systematic option. Sketch the beam. 4 meter, 6 meter, A, B, C. Take a section XX between A and C. I written here. Consider, that is, we want to prove the variation and systematically get the diagram. Consider section XX between A and C at X from A. So remember, at X from A, between A and C means X varies from 0 to 4. These all told for you. Start. Shear force here. Look this side. Plus 12 over. So constant. There is no X there. Now substitute X equal to 0, substitute X equal to 4. Irrespective of X equal to 0 or X equal to 4, answer will come 12 only. Why? Expression for shear force at XX is independent of X, means any value of X you put from 0 to 4, you cannot substitute beyond 4. So 0 to 4, you get 12. So later see, shearing force diagram and BMD also for AC portion will be here 12 and here 12. Starting 12 and 12. See, now this 12, you make a note. You should write here. Write here. You should write. You write. You write. This 12 kilonewton plus 12 we used to call earlier shearing force at C just to left of C. Because I told earlier, where point load is there, we have to do shear force twice. So this 12 is shear force at C just to left of C. Very important statement for our real concept. Our real concept goes round and round, that one only. Over. Then same section here, bending moment plus 12 into X. Linear variation. X put 0, Bm comes 0. When you put X equal to 4 meter, Bm will come 48 kN meter. Plot. 0 here, 48 here. Linear variation. So this is the SFD and BMD for our given beam only for AC portion. Yes, for AC will be as shown below. I have not done the complete BMD. I have done SFD BMD only for AC portion. Okay. Now I will consider for other part, that is CB. No, instead of CB, I will start from that side. I will call BC portion. It is your choice. You can start from anywhere. So AC completed. Now complete BC. Okay, I will start now. I will write here and then start. Okay, start. Remember, from here you start. See, last time I closed. Up to there you have to first write. Then you continue from there, but I have written here. Consider BC. Consider section XX between B and C at X from B. See, all the AC, I change to BC. I think I checked it. Nowhere mistake is there. Because there are people who will tell, he told BC, but still that last time A is still there. When people cannot find a technical mistake or mistake in solution, these are the mistakes they will search for. That is called desperate search. When nothing is wrong in the solution, then what to do? They want to find a mistake. Anybody see, sometimes the diagram may be slightly slantier. They will tell, see, it does not look like rectangle. Let them tell. Why should you bother? Okay, start. Now, section XX here, shear force here. Look this, one thing forgotten. Since you take X from here, varies from 0 to 6 meter. Start. Shear force here. Look right side. I told so many times, when you look right side, here also look right side. Right down is positive, right up is negative. It is -8. Once again constant. Put X equal to 0, put X equal to 6, you will get -8. Bm plus 8 into X. Linear variation, same as last time. Put X equal to 0, Bm is 0, Bm at B will come. When you put X equal to 6 meter, Bm at C will come plus 48. So, SFD BMD for BC, or see, they will tell, you write. See. Now they will tell, he wrote last time, highlighting forgotten. See, this is important for us. This side is not required. For B to C, SFD BMD is like this. Now, one note, you should write. You should write. What? This 8 kilometer, that is -8. See, with negative sign is there, that -8, so far we used to call shear force at C just to right of C. See, remember, earlier we got shear force at C just to left of C as plus 12, shear force at C, just to right of C, we got minus 8. That only is the real concept here. I will expand further. So many things told everywhere regarding discontinuity, continuity, non-differentiable. I will prove everything wrong today. I will give you crystal clear concept. But you have to have patience. Patience very important. I told class is meant for those who want to gain knowledge. Okay. Now what I will do is, therefore, as per our option 1, our final result I will write now. Okay. Now, therefore, as per option 1, I wrote somewhere earlier there, once SFD&BMD for AC, SFD&BMD for BC, I will join these two and draw the diagram here. Already over. It's already over. SFD&BMD for the complete beam. So as per option 1, right there, final result is SFD and BMD. Now, something told in the class earlier, or I will tell now, that you have to write. I will tell here, see, write all statements told here. Here means I am telling now. There is a principle. Shearing bending moment is maximum where shear force is 0. Rate of change of bending moment is shear force. Rate of change of bending moment is shear force is valid here also. I will prove it later when I go to real concept. Then, rate of change of shear force is intensity of load, correct, because there is no load in between. And further principle, for a function to be maximum or minimum, say y is f of x, dy by dx should be either, for a maximum or minimum, dy by dx should be 0. Here, for bending moment to be maximum, shear force should be 0. But there is no 0 shear force here. When somebody will ask you, or if somebody asks you, what is the shear force at C? Answer told by me earlier, up to now, or what universally people will tell is, at C, there is no definite shear force. There is a point load is there, shear force will suddenly change there, or at C, people use the word discontinuity, some non-singular, so many things are told. I will tell all that later. They will tell the non-differentiable, etc. for bending moment, all later. Now, so most popular answer, universal you get is shear force at C, just to left of C is plus 12, just to right of C is minus 8. That's what I also told, because it is not wrong. What is wrong is how they explain it. They tell something which I will not agree. I will prove it. But even I also will do same thing, because after all this discussion, finally I will tell that is not required. No one will do that way universally, and me also will do like this only. Correct. But the hidden concept or inner concept I will tell. Some will get now little curiosity. What is that one? Wait, I told earlier, you should have patience for this class. So this is SFD&BMD over. So here, or if you can write one more thing, he means me only, or elsewhere, people will tell bending moment is maximum where either shear force is absolutely 0. See, if you remember, when the diagram comes this way, absolutely 0, or where SFD will cross the baseline. Yes, I also told that way so far. Now also I am telling that way. From class number 101 also I will tell that way only. But people will tell something else. They will tell that concept of absolute 0 is not possible. No, you should tell either absolutely 0 or what, SFD will cross the baseline. But that I will prove wrong. That concept I will give you. Once again, later we will come back here only. This is only for this special class, class number 100, ultra special concept. See, now, all those things you write here. Now, little later, I will come to this diagram once again. Before I start discussing real concept, some extra discussions are there. Okay, leave it now. Now, come to option 2. That is shortcut or popular, universally popular. This also you know it. What you do? First find support reaction. Yes, already over. You know it. VA equal to 12, VB equal to 8 kilos. See, people find mistake. LN, no, K missing, rubbed out, 8 KN. Okay. But I should not bother about those things. Okay, then I told you earlier, sketch the beam after reactions are over. Sketch the beam neatly in a fresh page. Leave the space. No section solve. Easy method. Leave the space that is meant for SFD&BMD. Go for calculation. Start. I'll start from now. Now see, space problem is there. After you write the beam here, sketch the beam, leave the space, you should come here. See, you should come here. First, shear force calculation. I told you how to calculate. First write shear force at A. Slightly come inside. Look this side. Plus 12 over. This we have done it more than 100 times now. Then, next standard point, come to C. C there, you should write all these things. At C, there is a point load. If point load is there, you have to find shear force twice. First, you will find just to left because you are starting from left side. Just to left of C, then just to right of C. Start. Shear force at C, just to left of C equal to, copy the previous answer, 12. After C, till just to left of C, there is no load. So that's all, 12. Now, shear force at C, just to right of C. So just to left you got plus 12. When you go that side, suddenly down 20 is there. When you come from this side, this down 20 is minus. So minus 20, it becomes minus 8. Lastly, shear force at B, slightly come inside. Just to right of C, you got minus 8. After just to right of C, till B, no load, so minus 8. Then one statement you have to write. Shear force variation. Since there is no load between A and C and also between B and C, you can tell shear force is constant for AC and also BC portion. Okay, then now go back and draw SFD. Then I told you, by seeing these values, not required, you take calculator. Without showing calculation, you can draw. How I told? See, baseline here, right here, shearing force diagram. All values are in kilonewton. Left up, right down, positive. Then, see, go up by 12. It's all I told earlier. From here to here, no load. Go parallel to baseline, neither up nor down. Come down by 20. You are above by 12. When you come down by 20, you will come below the baseline by 8. Don't write minus 8. See, later you put plus here and minus here. This is the mistake so many commit. Once you write minus here, don't write minus 8. 8, numerically 8. It is minus. Then, from C to B, no load. See, 12, 8, somewhat scale. Go parallel to baseline. Lastly, go up by 8. Oh, SFD over. Then, below, draw BMD. Bending moment diagram. All values are in kilonewton meter. Sagging positive, usual. Okay, start. For BMD, Bm calculation, perform it. All standard point, find it. Bm at A, look this side, 0, over, no sections. Bm at C, look this side, plus 12 into 4, plus 48. Or, if you want, you can look that side, plus 8 into 6, same answer. Then, Bm at B, look this side, 0. Now, before going to BMD, draw variation. A to C, there is no load. When there is no load, I told so many times earlier, SF is constant, Bm is linear. So tell linear variation from A to C and again linear from B to C. So plot the values here. 0 here you got, 0 here. Here you got 48, 8 go that side. You got 48 here. Linear means, sometimes people call linear line. Linear means linear only. Plus here also plus. This is the bending moment diagram. Now, what all I told there, right here also. By seeing the shearing force diagram, if somebody asks you, what is the shear force at C? You should what I used to tell earlier, what universally told, at C there is no definite shear force. It is not defined. People's answer usually comes, it is not defined. I will define. Wait for some time. I will design. I will not design, so too many design problems. I will define. Now, but till now, what I was also telling, just to left of C, plus 12, just to right of C, minus 8. Okay, then maximum Bm is at the point where SF is 0 or SFD crosses baseline. In this case, where SFD crosses baseline, I told that way. That also is our discussion point over. BMD over. Our option 2 is complete. Okay, now we will go for our real concept. Real concept. You require more patience from now. I will make a memorable class here so that anybody who will go through this class should understand what is the real meaning of that just to left, just to right, and that bending moment maximum where shear force 0. What is the real logic? I will explain. Now, 1 minute. Everything is ready here. Now, before going to that one, I am going to ask a question. You should do one thing. The moment I ask the question, you should pause or stop. Not stop watching, pause. Try to answer the question. If you get the answer, good. Or if you don't get the answer, proceed further. You have to go to entire class, you will get the answer. Okay, now, question is, my question. What is either this diagram or that diagram? What is the shear force at C? I will ask. If someone tells, I know structural basic too much. I know everything. Okay, one question for you. At the end of this class, I am going to ask one more real brain teaser. Remember, real brain teaser. At the end of the class, a gift for you. Answer I may give later, not today. Okay, start here. My question to anybody. What is the shear force at C? He will tell me. Shear force at C is not defined. You cannot tell exactly shear force at C. Just to left of C, shear force is plus 12. Just to right of C, shear force is minus 8. Some country they may tell minus 12 plus 8. Okay, sign convention. Or numerically, just to left of C, 12. Just to right of C, 8. And SFD suddenly changes sign there. It will drop. From this side, it will drop. From this side, it will go up. Anyway, that's why I told. Jumps or falls, don't tell. Okay, that is the answer he will tell. Then I will raise my voice and tell. No, I am asking you what is the shear force at C. Explain. He will tell, no, it is not defined. Just to left, just to right, don't talk about that one. And my question is, what is the shear force at C? Most probably he will tell, not defined. Then I will tell him, suppose I define. He will tell, define. I need not define to him because he is not knowing subject. But still here I am defining. So that I am going to do now. So my question for you is, what is the shear force at C? What is the real meaning of the shear force at C? Don't tell me just to left, just to right. If you answer just to left, just to right, I am asking you. See, sometimes I am very adamant. I will stop the students. Some students will answer me, sir, I am asking you what is the shear force at C. Sir, we don't know. Tell that one. Sir, please tell, sir, later. For that matter, this concept, so far, I have not disclosed. I have kept it as a secret or what you call weapon. Today, I decided to make it public. I am not telling nobody is knowing. There will be very few people who know it. See, I am not telling I am the only one who is knowing. There will be people who know it, but they are not told you. But the other question at the end of the class I am asking, real brain teaser, that is ultra special. So many will get a shock out of that one. So many people those who got a quite good concept, they will get a shock. They will tell, This way question, you are really, this is a super question they will tell. But then, that also I will tell. I am not telling, I am the only one knowing it. Very, very few will be knowing it. But sometimes they know, they don't know how to express. So that I will ask you at the end of the class. This class, there is more discussion from me. Don't feel that way. He is telling same thing again and again. I told this, if you are serious, you will be happy to listen to all this one. So I will make more and more discussion also there. Now discussion will start when I go to real concept. Okay, you pause, think of your answer, write somewhere, then you continue the class, then see whether you are correct or wrong. Don't try to find whether I am correct or wrong. Why I am not telling. Okay, start. Now go to the real purpose of class number 100. I deliberately made it class number 100, century class, as a special class. See, from class 101, I will once again go back to continuation there. Where I stopped earlier, 99, I will continue there. This is in between special. Okay, I will continue. Now we will continue. See, first of all, I already given SFD&BMD as traditionally done everywhere, universally done, and also how I considered up to class number 99, that is previous class. Now, see, I written here, point load or concentrated load, red color, some statements are there. I am not going to write all the statement. This class is meant for those who are serious and want to get knowledge. So, what all I tell, if you understand and if you feel you will remember for lifetime, then don't write. Or if you think, no, there is a chance of confusion, better have a detailed notes or writings. Then what I am going to tell now onwards, write each and every word. I told this class will be a lengthy class because it is a complete clarification for a concept. And I will show you in the end that if the concept is clear and if everything, if you got a control on the basic knowledge, then how far you can go in structural engineering, that is level of knowledge. Okay, now, see, I am starting here now. You should write. There's some spaces here. I already wrote something. This I will tell you later. So now you are here. This place. Right. First one example. I am from India. My state is Karnataka. Capital city is Bangalore. And in Bangalore, in one of the residential area, I am here. This, see, this building is there. Or even this classroom is also there. See, this classroom, it is quite big here. You can feel here. There is lot of area here. Quite big, around 25 feet by 35 feet it is there. But suppose I consider the entire Bangalore, that is city. See, for example, I don't know how is the exact map of Bangalore. It is quite big. Entire Bangalore, if I consider. Not this particular residential layout. If I write the layout, a small I can show. Then this place, classroom, or even this building, you cannot show. It will just see a point. Furthermore, not possible. Why? So big is the city. Now, but if I consider this building, see, that side of some construction is there. If I consider this building, see, this building is something like this. Which I occupy is something like this. Yes, you can show it here. See, I can show it here. Or, for example, if I mark the road, this road is here. Then my building I can show like this. See, you can see here, it becomes smaller. But if I consider this local area layout, maybe little bigger. But if I want to show this place in the entire city of Bangalore, then see, over. And If I want to show in the entire state of Karnataka, again same thing. Very small dot. Pin. Small sharp edge of that pin. Or if I want to show in India, very difficult. Why? In India, Karnataka itself looks so small. See, if you put Indian map, your Karnataka itself is so small. This much it comes. There, Bangalore is almost a dot. Or if I see the entire world, then not only my building where I am staying, not only this local area, and even the Bangalore city, and for that matter, even our entire state also is so small. But India, we can see little bigger, not very bigger. If I show the entire world map here, somewhere here, this way India will come. Now, if I consider entire universe, unlimited, galaxy, etc., then even our Earth also is a point. Why? So small. Therefore, why I am telling this is, now come back here and write. Practically, it is impossible to apply a point load or concentrated load. See, for a member, for example, our example also is there. Suppose for a beam, for example, practically it is not possible to apply a point load. It is impossible. There should be some contact area. See, like this, I told this building, in the world map I can't show it, dot. In India also dot. In Bangalore city also dot. But if I come to the local residential area, it becomes slightly bigger. If I come to this road, it becomes little more bigger. If I consider the building, entire building, then which I am occupying is quite reasonable. See, it is nearly around 40 to 50%. Therefore, it is practically impossible to apply a point load. There should be a contact area. See, if I apply a load, for example, see, suppose there is a beam. I'll show it here. Suppose there is a beam resting here, supported by columns. Okay, I'll put arrow mark only, sufficient. If a slab is resting there on the beam, the slab load will be spread. See, it need not be UDL, it can be UVL. So many shapes are there, not required. Time being, I am not going to RCC part all, etc. It is spread. See, you imagine a beam slab, load is spread. It is not point load. But suppose there is a secondary beam in the main beam. A secondary beam will come and sit here. Then depends upon the width of the beam. Suppose the width of the beam is quite reasonable. See, if this the secondary beam goes, then you can tell for this beam, whatever load comes is spread here. See, it need not be UDL. I will tell you it later. It need not be UDL. It can be UVL also. See, slight tilted this way means more intensity there. Or suppose you take column, footing, column and footing resting on soil. Column load you take usually point load like this. The pressure from footing below is taken UDL usually for practical purpose, but it is not UDL. Depends upon subgrade soil reaction. It can be so many different types, some cohesive soil, clay soil, that I am not bothered here. See, the pressure will you take like this pressure. Usually you take like this. Sometimes it can be like this also. Or sometimes even it can be like this also. Or even this way also possible. But what is important is there is a contact length or contact area. One-dimensional member, you take contact length. Two-dimensional member, you take contact area. So now, see, I already told lengthy class, but you stand to gain lot of concept. Some doubts which remains, which is there, will be completely eliminated. See, suppose I have a second main beam here. See, for example, upspan, even this point also is not there. See, first of all, this also is not there. Even the column has got some contact. Actually, the reaction comes this way. But we are discussing beam now, so no problem. There is a limit for discussion. See, Or I'll put it this way, okay. This way is much better. Column or beam or wall. See, suppose the secondary beam resting here, imagine this beam span center to center is around 10 meter. Same as our beam. See, our beam also 10 meter. Okay, now, if there is a beam, say for example, a wide beam, sometime some wide beam will come. If the wide beam rests here, say for example, for around wide beam, say 1.5 meter width, sometime possible, then the load will come like this. It need not be UDL, it can have other variation, but important is what? There is distributed load. Our discussion, we take UDL. Whether it is UDL or UVL, what I want to tell is valid. So, instead of making more complication, you take UDL. That is uniform pressure. Okay. Now, suppose by chance, if the secondary beam width is only 0.3 meter, that is 300 millimeter. See, 10 meter span, a secondary beam will come and rest for 300 millimeter. Then the load is transferred here for only 300 millimeter or 0.3 meter. Now, if you look from nearby here, you can see the spread load. If you go away and away from the beam, then suddenly this length looks smaller. Correct? Length looks smaller. Therefore, now what you can do is, people can replace this distributed load by a point load here. Then you can take point load, because if you replace that UDL by a point load, the error for bending moment and shear force diagram will be minute, not much. I will prove it all. I am going to prove it now. But or, suppose the beam width is further lesser. It is only small beam. See, I can see a small beam here of width only around, I don't know, it's actually a steel beam actually. Its width is around 20 millimeter. Steel plate is there, 20 mm. Then the load will be spread on this, see, 10 meter span. 10 meter span, it is actually, see, this way. This you can take almost point load. Therefore, when you consider a point load or concentrated load, it is impossible to apply a load at a point. Then intensity becomes infinity. See, intensity of the load means what? Whatever is the load divided by loaded length. See, for example, suppose the load here. See, our class load is how much? 20 kilonewton load. If you spread it for, my first example is for 2 meter. If I spread for 2 meter, then the UDL will become 20 kN total load for a length up to 20 by 2 equal to 10 kN per meter. See here, I wrote 10 kN per meter. Next I will go for example, not 2 meter, I will go for 1 meter. 1 meter. Then this will become 20 by 1 equal to 20 kN per meter. Okay, then further. Then I will go further. I will not go for 0.1 meter, I will go for lesser number. Say, for example, a beam of width 400 millimeter. I will make a note how much I have taken. First 2 meter, then 1 meter for my reference. Otherwise, later you will tell, you told something else earlier. Now you changed it. I will make a note here. First I took for 2, then I took for 1. Okay. I will take for 400 millimeter. I will make a note. That is beam of around 20 inches width, little wide beam. Then, if it is 400 millimeter, load will come this way. See, total equal to how much? 20 kilonewton. Distributed length is how much? 0.4 meter. So, this intensity becomes 20 by 0.4 equal to, so much used to calculator, long back in high school, I have done it directly without calculator. Now, too much addiction of calculator, what to do? 50 kilonewton per meter. Actually, when you write 50 kilonewton per meter, 1 meter need not be there. If it is 1 meter, then 50 kN. So, total load is what? 50 into 0.4 is 20. Now, for a span of 10 meter, load spread for 0.4 meter, if you look from a far distance, it will almost look like a point. So, if you replace it by a point load of how much? 50 into 0.4 is 20 only. 20, then the error in SF and BM coordinates in the SFD and BMD will be very small, practically okay. Or further, then I'll go for, after 0.4 meter, I'll go to only 0.2 meter. I'll make a note because I'm using same value. 0.2 meter. If it is 0.2 meter, see what happens now. If it is 0.2 meter, see, loaded length is 0.2 meter. So intensity becomes 20 divided by 0.2 is, if I got 50 there, 100 kN per meter. If 1 meter is there, 100, but only 0.2 is there. Total load remains same. Now, it will almost become like a point load. But still remember, there is a contact length of 0.2 meter. Even though you take a point load of 20 kN, it is actually, if it is a uniformly spread, if it is non-uniformly spread also, total load is same. But there is a limit for discussion. Once you understand this one, you understand everything. See, even for UVL also, you know shear force diagram all. So, if you replace this load of 100 kN per meter or 20 kilonewton spread over a length of 0.2 meter only, then it will have an intensity of 100 kN per meter spread for 0.2 meter, means total 20. If you replace it by a point load of 20 kN, then the error in SF and BM will be quite small. Practical design, it is okay, because design point of view, such small things are not considered. Rounding of error. Or one more thing you can make out now, it will give you slightly higher BM than the actual BM. If the actual BM produced is 100 units, this due to actual UDL, if you consider load spread for that length, if the BM comes 100, this may come 100.2, 100.3, little more. Again remember, when for a designer, he will design for not 100, 100.1 or 100.2, etc. So he will design the beam for resisting little more BM. Or in the design field, when you consider a critical case, it is always on safer side. So since this, like you think what expense is going to be how much? 100 rupees. Rupees Indian currency. Suppose for safety you take 5 rupees more. Yes, good that way. So what BM actually comes by when you replace by a point load, it will give slightly more BM, therefore safer side. Or even if it is little this side, that side, no problem, because say in $100 or rupee like that, that 10 paisa, 20 paisa in India or 10 cents, 20 cents is nothing. Now, what I will do is, I told I will spread the load for 2 meter, then for 1 meter, then 0.4 meter, then for 0.2 meter. Okay. For all this one, I will draw the SFD&BMD. Then I will do one thing. To get more control, I will spread it for further lesser length. I will spread it for only 0.1 meter. Very small length. Then the error will keep on reducing. Means it will approach to the value which you got last time. Then just to understand, I will further continue after 0.1 meter, further lesser. Why? Imagine very small contact length. If the contact length is very small, then it can be taken point load. Okay. So I will tell you now, after 0.1, I will go for 0.05. That is actually how much? 0.05 is how much? 50 millimeter or 5 centimeter. Okay. Then I will go further for 0.01, just for 1 centimeter. I will further go for, then I will jump to 0.001. See, like I told in the world 0.001, and I will further go to 0.000. I have not decided, I will tell later. Like I told, this building in the world map is a point. In Asia, Asia, again it's a point, but little bigger actually point. When you come to India, point only, but slightly more. Or when you come to what? When you come to Bangalore city or Karnataka, our state Karnataka, still point. Come to Bangalore city, still point. But come to this road, it is not a point. You can see that distributed length when you come nearby. So, therefore, if the load is spread for 2 meter or 1.5 meter, then you can take UDL. Then if you replace by point load, again safer side only, but it will give unnecessary higher BM than actual BM. Design becomes uneconomical. See, replacing UDL by point load for BM always gives you higher than the actual BM. Safer side, no doubt, but economy will not be there. So next I will tell later. Or what I will do is, I will get the answer for initially 1 or 2. In front of you, I will draw the diagram. How I calculate, you don't bother. And one more thing, remember, for a simply supported beam, when a partial UDL is there, not symmetrical, unsymmetrical only. What I will do is, each time I will spread whatever loaded length I decided, half this side, half that side, so that our point here, see, that point C come to middle point. Like load is anywhere, our load is where? At 4 meters from left, I can take center. But if I show center, problem is, permanently maximum BM will come at center. So concept you can't learn. By taking eccentric, you can make out slowly the point of maximum BM will slowly move towards that point C. Finally, it will come and almost touch the point. That is where point load. So therefore, so what I will do, when I take 2 meter here, I will take C here, I will take 1 meter this side, 1 meter that side. When I take 1 meter here, I will take 0.5 here, 0.5 here. When I take next how much? 0.4 meter, I will take 0.2 meter, 0.2 meter. See, when I take point, not 1, etc., scale is not possible, little exaggeration. Okay, or I will put a cut diagram at that time. Now, such question where, see, a simply support beam where a partial UDL is there, eccentric, some other distances. For this one, SFD&BMD principles all are over in my earlier class. Same question solved there. With full explanation, I solved. Therefore, today's class is not teaching of that one. I will not tell you how to draw SFD&BMD here. Then if somebody will ask, sir, SFD&BMD not clear. If not clear, go to that class earlier. Shearing force and bending moment diagram for partial UDL. One class I solved for, see, once I considered here, then I consider this side, then I consider somewhere in between, once symmetrical, once unsymmetrical. You study unsymmetrical, 100 times study it. When you get to, if you want to learn everything, including proof, master that question. I will do one thing now. Little later, I will see my YouTube videos. Sorry, I don't call it as videos actually. It came because they call video. See, this sorry I will tell. YouTube classes, I give value for education. When I will observe that YouTube classes and exact tell you which class number, because I am going to clean this one now. Which class you have to refer, so that here I will just draw. I will directly draw. I don't require calculations all. I will take calculator and draw here. How you don't bother. And one more thing I will do. After some 2-3 values, how much I told? 2, 1 and 0.4, then I will derive a formula for directly getting what all you require. A formula will be there, so you can do the calculation. But our final conclusion is what? Is real concept of shear force at the point of concentrated load, and furthermore concept, people telling at the point of, so many people I have seen shouting in the classes, online classes. Even someone asked a doubt, a student asked a doubt recently in some class, sir, what is the shear force at that point, sir? He used some very hard language. He told him, I don't want to tell all the things all. How many times I have tell you, I told earlier, it is not defined. It is either to left or right you have to see, exactly at the point, there is no shear force. Sir, that point of maximum BM where shear force 0, he told there, no, that is valid only when the shear force diagram crosses this way, not when SFD suddenly crosses baseline. It is not valid. It is we will use the word discontinuous, singular function, non-differentiable. I will prove everything wrong. It may hurt them, but no problem. If it hurts them also, at least They will learn something. They should feel that way. Oh, I made all the mistake earlier, telling something which is actually not correct. I will advise one thing for them. Unless you got full control or full knowledge, do not put comment unnecessarily that this is not possible, that is not possible. Who knows? You think it is not possible. It may possible. I will make it possible here. The purpose of this class, I told you, long class. I will talk more. Hope you are enjoying the talk. If anybody feels non-stop talking, then don't continue. I told, don't continue. Who told you to go through the class? But I will tell. So this all I don't want. If you don't want this one, leave it. What do you want? I want SFD&BMD. Go to class number 101. Class number 99, jump to 101. Skip this one. Meant for those who are sincere and want to understand. I'll continue now. First see, 1 minute. I'll remove the board so that before that, I want to tell little more here. This I'll remove. I made a note there. Further, I don't know what I told. This also I'll remove. But remember, these points, what all I told, in your own language, you write everything here. Some will tell, sir, already 10 pages it will come. How many pages? Your choice. Those who want to learn more, they will write more. Okay. Or go through the class again and again. Your choice. Right here. Now, 1 minute. I want to check the camera. Sometimes slight tilted it is. Because little high wind breeze. Okay, no problem. See, after all this talking, if I find that some portion is not visible, it hurts to do recording once again. Suppose I do recording once again for some reason, I will not talk the same way. I never come prepared. If you ask me to take the same subject after hearing this one, if someone invites me, we want a lecture in the college about this concept for students. And if they compare that, record that lecture and this lecture, they will be different. Point will be same. That is same if you by heart and go. I never by heart. I told pen for recorded class, calculator. That's all I require. Okay, now I will start now. See, now I told so many things now. Conclusion is what? It is impossible to apply a point load. See, I will tell you conclusion now. It is impossible to apply a point load. There should be some loaded length. See, this room, it may look a point in the world map or Indian map or state map or Bangalore city map. But when you come here, there is an area, quantity, there is some area. Otherwise, how I can live here? So there is enough space here for me. But same buildings become so small when if I go to universe, first of all, you can't imagine this place. So now make a note here. Our example is simply supported beam of span 10 meter. A point A, point B here, I think visible from there. I have gone slightly left side now. Okay, let's start here. A, B, our span was last time, past tense, 10 meter. A point C here, we applied a point load of 20 kilonewton, prepared SFD&BMD for that one. Your SFD came. This is 4 meter. $12, 8, sign value I am not writing. BMD came like this. 48, this is the SFD&BMD you got. Then I told something, people will tell shear force at C just to left is 12, just right is -8, BM is 48, and this dip where BM is maximum, where SFD crosses the baseline, zero shear force does not exist there. This is what people will tell. This is all I told last time. Now, this 20 kN load, now I am replacing by the real load. Because I told it is not possible to apply a point load. So I will start from load applied for a longer length. How much I told? Forgot, 2 meter. See, first. Now consider the same beam, that is simply supported beam of span 10 meter, subjected to the same load, that is 20 kN. But not as a point load, because impossible practically. Not as a point load, instead as an UDL spread over some length, say 2 meter for example 1. For sub-example, I will put here, for sub-example 1. Sub-example 1 dot. Okay, 1 dot is 2 meter. Then I will write 2 dot, 3 dot, 4 dot like that. 2 dot, 1 dot. With center of the UDL, see, center of the UDL correctly coinciding with the point C. Center of UDL, where is it? With the point load, 20 kilonewton. With center, yeah, entire center of UDL at the same point where previously we considered point load of 20 kN. I should close the bracket. See, okay. No bracket. Okay. With, okay, no problem. See, so the statement is same beam, the point load. Now you consider, imagine to be spread. It should be spread for some length. Only point not possible. So imagine longer length. Spread for length of 2 meter. In the 2 meter spread length, 1 meter will come to left of the C, 1 meter goes to right of the C. Then draw SFD&BMD. I will not explain how to draw because already over. Now, see, first you have to find reactions. Total 20 kN. 2 meter spread. So it will become 20 kN. Intensity, it will rubbed out here because of touching here. Intensity of UDL equal to 20 kN load spread for 2 meter, it becomes 10 kN per meter. So now you have to draw SFD&BMD for a beam of length 10 meter, UDL of 10 kN per meter, total 20 kN, where 1 meter is this side, 1 meter is that side. So this gap is 3, that gap is 5, this is 4 and 6 meter. SFD&BMD required. Now observe one thing, as the contact length becomes lesser and lesser, intensity will become more. It becomes more, intensity is more. Like as the time is lesser for you, for studying a subject, intensity of studying should be more, same way. Now, I told some 0.001, it may come in lakhs also, okay, but if it is if the contact point has no distance, exactly point load, then intensity becomes infinity, not possible. See, so therefore later as I continue further, as I go for lesser and lesser length, means I am going towards that side where you can replace UDL by a point load, error will be lesser, then intensity keeps on decreasing, but total load remains same. Now see, find reaction. Minus VB into 10 plus 10 into 2 into either 3 plus half of 2 or 3 plus this one or directly 4 equal to 0. I told reaction. Note, I will tell in the class. See, now you are right. That clearly shows that if you spread half the load this side, half the load that side, then whatever is the length of the load you are considering, that distributed length, reaction will not change. See, last time also you got 12 and 8, now also 12 and 8. Suppose as I make lesser and lesser here, resultant load will pass here only. See, when you take moment, even if you make this length lesser, total load into 4 only. Therefore, you should make a note. All the example now onwards, I will not bother about reaction. As I reduce the loaded length, intensity will increase. That shear force where the shear force variation will change, Bm value will change, but support reaction will still remain. That side 12 kN, correct? Yes. This side 8 kN. That I will not tell once again. Those who want concept, this will be clear. Okay, now I will prepare the solution here. See, I will prepare solution here. Okay, I will prepare in front of you only so that you can see how easy it is. I will get the solution here and then I will note down in the YouTube what is that class number where this type of question is solved systematically. Those who find difficulty, see, our class is not to draw SFD&BMD. Our class is observation. You are knowing how to draw SFD&BMD. If anybody tells, suppose some little confusion is there, I will tell, go to that class, solve that problem. How many times? 100 times. Then come here. Then you will tell, oh, easy, understood. Okay, I will start now. Okay, we will start now. See, I return here. class number 46, where I don't remember now, this question is given. I don't know, span is actually most probably 10 meter only, I think. I don't remember exactly. You can see UDL for intensity given there, and these two are not equal. That question is the key question for solving this one now. That is our, when you considering the distributed load here, it is very important. First you study thoroughly class number 46. Then understand everything. See, this class is not for explaining SFD&BMD for that partial UDL, already over. My purpose is something else. So now I will draw the SFD&BMD. Anybody gets difficulty, go to class 46, study and then come back. See, I will draw SFD&BMD now. Go up by 12. From here up to here, I am not naming this point. See, there is no load, come parallel to baseline. Here it is till 12. When you reach here, come down by how much? 110 kN per meter for 2 meter or 20 kN. Correctly, when you reach here, see, this point here, when you reach here, it will come down 8. So, it will come like this. Then, no load, go back here, 8. So, your shear force, now compare the diagram there, see, this will be permanently there. This is when you consider point load. Now, compare the two. See, one more thing, I will draw the diagram. And this point you require to locate. What I will do is, I will locate that point from here. See, from here. How to locate, I will not tell. 12 by 10. It will come 1.2 meter. See, this is coming 1.2 meter. I will round off this one. That is 1.2 meter means, remember, from here to here is 1 meter. So, if I consider from here to right side, it is 0.2 meter. That is the point where shear force is 0 is at 0.2 meter to right of C. Right? It will be permanent right of C only. Now, draw the bending moment diagram. Bending moment here, I am not interested actually. Not interested, but still I will calculate. 12 into 3, 36. See, this point BM is not important for me. This point BM is not important for me. See, scale is not possible here. I write it, sir. You write a big scale if you want. See, these are not important. Still for, now I will write 12 into 3, 36 is here. Here it is 8 into 5, 40. It will be 40 here. And now, this is straight line. This is straight line, that is same as there. But then, through this point, you get the maximum BM. I will use a color here. How it will come? It will come parabolic variation. Same tangent, parabolic, actually out of scale. It will not come that much actually. So, little exaggerated, okay. Little exaggerated. Or I will do one thing. Okay, no problem. I will first calculate what is that value. Calculate here. I will tell you how to calculate. It is 12 into 4 meter plus 0.2 is 4.2 minus 10 into 4.2 square divided by 2. No, wrong. 10 into 4.2 square. 12 into 4.2 minus 10 into 1.2 square, because I got less than this value. 1.2 square divided by 2 is 43.2. See, it is red color I will put here. 43.2, that is the maximum BM. It will be a parabolic variation. It will come this way. Okay, parabola, from here to here is parabola. I put red color for parabola, partial red, parabola. Therefore, see now, come here. One table I will make now. When loaded length is 2 meter, distance of point of zero shear force from C, that is where BM is maximum, is at where? Is at 0.2 meter. 0.2 meter to distance of point of zero shear force. I can do one thing from C, further I can write from C, it is to right of C. Why right every time? It is 100% right of C, I know it. Right of C, where BM is maximum. BM is maximum. Then I want maximum Bm is 0.2 meter. Directly I can put the answer 0.2 meter. I put red color for that one. 0.2 meter. And maximum Bm is 43.2 kilonewton meter. Now do one thing. Write a note. When you replace, see here, for every time you get here, you make a note here. You write. When you consider this load as a point load at C, maximum Bm was 48. Shear force just to left of C is 12, just to right of C is minus. It is actually not 6, actually 8. Okay, 8. But here, 12 is the shear force at the left end of the UDL, 8 is right end. Here, 12 to minus 8 suddenly drops, but actually it gradually changes. See, it is not suddenly. There is a point of zero shear force here. That point I will not take. I will take the point as x if you want. Unknown point x. Okay. X point will come at. You can take this, and that all you can see in class number 46. You take distance x. That I will not tell here. Over. Now, 2 meter over. Now, as I committed, loaded length, how much I told? I told 1 meter. 1 meter. I am reducing the load. So, if it is 1 meter, do the same way. You should do it. I am not going to do. I will tell the answer directly for you. If it is 1 meter, it will be distance from the point of maximum Bm from here to that side will be 0.1 meter. I am so sure. 0.1 meter. You work out. 0.1 meter. Correct? 0.1 meter. Let me check. 12 divided by intensity will become 20 kN per meter. Yes, 0.1 meter. Then maximum Bm will come. I will just give homework for you. 12 into it is 0.1 means 4.1 minus 20 into 0.6 square divided by 2. 45.6. 45.6. 45.6 kN meter or 1 meter. 40 minus, just checking it. 2.4 into 1. 45.6. So correct. Over. Now, after 1 meter, next I committed for 0.4 meter. I am reducing. This I will do it here in front of you. 0.4 meter, I will do it in front of you. One homework for you. Okay. It happens. Right time I don't get the paper. Okay. That 0.2 meter, I will do it here. Now this I will remove. In front of you only. Then I will tell some important concept there. Now only I will explain. Then I will continue for further length. See, little space problem is there, or I will do it, I can do it here. See, space problem, okay, no, here only I will do it. So, see, available space, sufficient. Understand, you write a big sketch if you want. See, more and more length you take, it will become more clear for you. That is for those who are serious. I told repeatedly for you, this point is here, C is 4 meter. This is 4 meter. I will do in front of you only. This is 6. Little scale I am not maintaining, 6 meter. I will take loaded length very small. See, that's all. Sufficient here. Furthermore, I can't go because restriction here. This length I am taking 0.4 meter. Very small length. That is, maybe a beam of span 10 meter, a secondary beam is resting only for 400 millimeter. Now you can take almost like a point load. But still I will tell something else here now. See, now, if it is from I told correctly what? That secondary beam is resting so that its center is exactly here. This point is C. So, either side distance is 0.2. 0.2 meter and 0.2 meter. And intensity will be 20 kN is the total load divided by 0.4 will become 50 kN per meter. But even if it is 50, sometimes student will tell, sir, last time lesser, why lesser? 50 into 0.4, load remains same. The contact length decreased. Okay, now this is, I already told you, VAVB will never change as long as this point is maintained. How much? 12 kilonewton. And this is 8 kilonewton. See now, SFD. I will draw SFD here. Go up by 12. Then come, see, I can't exactly mark here. This point I will mark. See what I am doing? Constant. Then I will mark this point. See, this point I will mark. Come down by 50 into 0.4 is 20. So it will come this way. How much here? 8. It will go this way. Now you can see the diagram is approaching that diagram. See there? Last time it was this way. Now slowly it is tilting. See? The SFD is slowly tilting. See now? Or if you see from a distance now, you will tell compared to this one, slightly inclined. Okay. Now, this point you require. How to locate that point is your problem. I told you, from here to here, you take x. X will come. I can directly use maximum Bm only, first of all. I don't require this one. But you should practice, you should 12 divided by 0.24 meter. If x will come, I'll put here now, that x will come 0.24 meter. That is, see, earlier it was at, first time it was at what distance? From here, 0.24 meter means from center to that point of zero shear force is only 0.04. Correct? Yes, very small distance. See, when the loaded length was 4 meter, loaded length was how much? 2 meter. It was at how much distance? 2 meter means 0.2 meter from here. Then little earlier it became 0.1. Now it became what? 0.04 meter. See, that is the point is slowly coming nearby. It is that point of maximum bending moment or where shear force 0 is coming near to the point C. Or now if you draw minus plus are not required, I won't write waste time writing kilonewton shear force diagram sign all. Or now Bm value, if you find Bm here and find Bm here and also Bm at this point, available space, scale I am not maintaining, Bm here will come, here. If it is, how much it is? If it is 4, this is 0.2 means it is 3.8. 12 into bracket 3.8 plus other is 0.24 minus UDL is 50 into where it is 0.24 square divided by 2. 47.04 is a maximum Bm. See, it is 47.04 is a maximum Bm. These two Bms are not required, but I will calculate if you want. 12 into 3.8. It is 45.6. See, approaching near now. See, these two are becoming almost equal now. Very, not almost equal. And that Bm is 8 into, from 6 subtract 0.2, 5.8. 46.4. This is little more. 46.4. This is straight. Okay, no, hand slipped. This is linear straight. This is straight. This is parabolic. See, peak value here. Zero shear force here. 47.04. Now when it is 0.4, from this point, the maximum Bm point or where shear force is 0, I wrote here, is very near. It's only at 0.04 meter. 0.04 meter is how much? Almost you can tell here only, slightly right side. And that is the point where shear force 0. Therefore, do not tell zero shear force is not existing. People who tell, don't tell nonsense. When a point load is there, shear just to left, just right are the shear forces there. There is no concept of shear force at that point. No, don't tell those things. We are idealizing it as like this later. Sorry for those who were telling like this earlier. At least from today onwards, correct yourself. And now see, maximum Bm came 47.04 kilonewton meter. Remember, our maximum is 48. We are approaching 48. Okay, now I will do one thing now. For this one, some reason is there now. See, for this one, I want to explain something more. I can explain it later when I go for a smaller length. But then length becomes too small. Length becomes too small then. Or 1 minute. Okay, I will explain it later, better. Now I will go for it's a 0.4 meter. What I committed earlier, I don't remember. Written anywhere? Okay. 0.1 meter. Okay, 0.1 meter. Very small loaded length. 100 mm. Okay, now I will tell how much distance you work out. You take this as 0.1 meter, 0.05, 0.05. Class number, what is that one? 46, huh? Forgotten. Go there, study and come back. Or here the diagram is, plotting is not my problem. Concept is the problem. Here value will come, the distance will come. What is the length? 0.1. 0.06 meter from left end or 0.01 meter. 0.01 meter to right of C means, oh, very nearby. Okay. Then the maximum Bm will come. This you calculate. Where is the reaction here? Reaction 8. 47.76. Oh, we are approaching what? We are approaching 48 kN meter. See, as the loaded length slowly reduces, the result almost comes near to our result of point load. 47.76 kN meter. If by chance, if any calculation mistake is there, you correct it. Okay. Or I will do one thing. At the end of this one, I will derive a formula for maximum Bm and Bm. And for even this distance also, I will derive a formula. Then we will apply cross-check. The formula I will derive, no problem. Very simple formula derive. You cross-check. Then, if anything is not telling, I will tell at that time calculation mistake, now correct it. Okay, now I will go for next. After 0.1 meter, I will go for very small length, 0.04 meter. Some will tell what he has gone mad. 4 centimeter, that's all. The contact point is see like this. Now see what happens now. If it is 0.04 meter, your distance will come. This 0.04 is not this 0.04. Okay, now leave it now. I will make not 0.04. I will put a 0.02. Okay, 0.02. Okay, 0.02. Otherwise, some will think it is same this distance. No, 0.02. Your value will come then 0.012 minus 0.01. From center, it will be 0.002 meter. 0.002 meter. And the maximum Bm will come. I have to calculate now that intensity. Okay. How much? 0.02. 47 point, I think most probably correct. 952. Oh, approaching 48 kN meter. I will do one thing now. To make the perfect here, I will go for 0.002. 0.002. 2 mm. Okay. Then this will come. You never bother how I am getting it. Center minus 0.001. Sometimes people ask me, sir, how you are getting, sir? You never bother about those things. 0.008 meter. Let me check once again. No, I got doubt now. No, 0.000, one more knot, sorry, 8 knots. How many knots? 3 knots. 0.002. That is something else. The X came, okay, the intensity keeps on increasing. Okay, now further, for that one, I think correct. If wrong, we'll correct later. See, what will happen? Numerical problem. See, I have to imagine everything. I can't see this diagram. I have to imagine and calculate bending moment. Then the maximum Bm will come. 4 minus 0.002. Okay. 47 point, approaching 9952 meter, kilonewton meter. Now, to make further perfect, I will do one thing now. Sufficient point, see space problem, not, one more not, enjoy, one more not, 1. Very so small pin, but still contact point is there. Like what? Like a knife, sharp knife is placed on the beam. Even then there is what? There is a contact. There is some contact length. Now I am going to stop now. Last one, sufficient. Next is 0 only. Last one. Now this value will come. Point not. How many knots? 5 knots. 1, 2. Intensity there. Very difficult. It is point not 1, 2, 3, 4, 5, 6. 6 knots and 1. Some link is there, don't bother. There is some link. You will prove it now. I am not using any link now. I am imagining the loading diagram, imagining the shear force there, locating the point where shear force is 0, finding maximum. But actually finding maximum, I don't require this one. You know, I got direct solution. Okay. Some tricks are there with me. Now the BM will come. Point not 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I should be careful. 47.99976. Oh, so the point is now coming closer. You should write all those notes. So now lastly I will tell, in case you take 0, it becomes point load. Why? No contact length. But it is actually somewhat like nonsense because it is not possible. 0 means, see, then if you calculate, you will get back once again 20 kN. But one problem, then intensity becomes infinity. 0 is not possible. There should, see, I told you, you cannot stay in a building where there is no area. Compared to galaxy or world map, it may be a point. Compared to India, it can be a point. Compared to Karnataka, can be a point. Little bigger point. But as I come near and near to this one, as I condense the map area, if I put a Bangalore map, little bigger. If I put the map of the surrounding area around, say, one small layout, then reasonably bigger. If I put a map of this road or this building hall, then this place becomes quite bigger. So that's, I start reverse way here. So that is 47.99999. You can write here, that is almost equal to 48. Yes, that is the BM here. Then shear force diagram will be, I will put the shear force diagram for you. How is the shear force diagram for the last case? I will explain once again. And for 0.04, this one, I will give one more concept. Fitting reply for those who tell not differentiable for them. People who use the word, it is not differentiable. So many places I heard it telling it is not differentiable. See, my purpose is not to hurt them or expose them like that. But if you tell something wrong, it is wrong. Therefore, what I want sincerely is they should learn by their mistake and understand the concept. Now so many will tell, this you are knowing. I will tell, if you are knowing, why you not told? No, I thought it is not required. It is required. What? It is not required. It is required. Then I will tell you are not told because it never came to your mind. You never thought of this one. You are only telling singularity, continuity, discontinuity, non-differentiable, something which is not correct. No, they are correct in mathematics. But here, there is a real concept is there. Now I will do one thing now. For 0.04, this one, see diagram is still there. I will prove that differentiation, etc. I will prove it. I can prove for this one because what happens is, for this one, it is so small. Writing is difficult. Point not now. I have to keep on counting. 1, 2, 3, 4, 5, 6. Sometimes I have to count in my local language, my mother tongue language. Because why? Usually when I want to add something, 12 plus 8. Okay, 20. But usually what I do, if you don't know language, no problem. I will tell 12 8 20. See, when you add and multiply, usually, because my medium of study was that in the beginning, I can do only in that language. I cannot do in English language. But using calculator, I can do it. Naturally, suppose you want 4 plus 5, 4, 5, 9. It came. Sorry if you are not knowing that. It is a Kannada language. Okay, therefore, I will do one thing now. I will remove everything now here. So remember, this I will not remove. This will be there. This I will explain further. Then I will tell the differentiation concept and then close the class. Then I am thinking, shall I ask that real brain twister question today or not? Most probably today only I will ask to make it complete. People who suppose somebody will tell, no, this or I am knowing actually. Okay, no. Okay, you are knowing. Then answer this question. Then he can't tell I am knowing. If you are knowing, answer it in the comment box. You can tell them. If you are knowing, answer in the comment box. No, that I am not knowing. Then why you are telling? Once I tell something, you should not tell I am knowing. You should tell I learned. Okay. This also will be there for some time. I will get ready once again. Now, for further more concept and to understand that differentiation all, I decided to take the case of 0.02. See, one of them answer, 0.02. If I take 0.0002, become too small. So, even 0.02 also very small. But still, see, diagram I written here. Once again I wrote here. Just now I given earlier, I wrote once again here, the values. See, 3.99, 0.01, 0.01, maximum BM point slightly right side by 0.012 meter. From 0.012 from here. Or from here, I forgot right. From this point, see, actually from the point center here, I write here now, see. From the point C is somewhere here. See, C is here. The shifting is only, how much it is? 0.002 meter. Not meter, it is almost C only. Now see, diagram I wrote. This way, this is exaggerated because when this is 10 meter, this looks like around 1 meter, out of scale. Actually, see, I written here, this diagram is actually like this, actually further lesser. See, you can see here, small load. See, still not coming. I'll use other pen so that because this pen is little sharp, because it's sharp, it spreads there. See. Okay, that way. Okay, I'll put a color. Hope it will not change. Okay, this way. Now, see. 12 and 8 drop. This is actually too closer. Actually, it is see, like this. Not exactly vertical. See, slightly. How? Very, very small angle. We get the slope later for this one. Okay, then maximum BM diagram is here. See, actually from here to here, see, a small portion, very, very small portion is parabolic. I can't show further here. See, very small portion is parabolic. Now, this is almost like, see, there. Compare this one. You should tell. If you look from a long distance, somebody will tell both are same. Don't tell the scale. It is bigger there, smaller here. It is almost same. Okay. Now, just 2 more points. One, people tell non-differentiable, etc. I will give the answer. See, I will do one thing now. Correctly observe. This I will remove. I want some writing here. That I will remove here. so that I get space. That I want it. I'll use the space here. What all I write, you write correctly. You write correctly. See, what you do is, this actually, remember, this is very small. Okay, now, I will take a section here. See, I don't want to disturb the diagram here. I will take a section here at x from here. Don't worry about that x. That x is later. Now, for the AD portion, I want to use color now. Shear force at x equal to, as usual, left up, right down, positive, equal to plus 12. Now, x will not come. That's why it is constant. These all told in class number 1 to 99. Now, you know that if you differentiate Vx, dVx by dx, if you differentiate, how much you get? 0. Correct. Why? Because you should write rate of change of shear force is intensity of load. See, there is no loading here, 0 came. You should write everything if you want. I cannot write because space is not there. Then, also, I want mx, bending moment here. See, 12 into x plus 12 into x. If you differentiate dm by dx equal to plus 12. Or you can tell rate of change of bending moment is 12. You know that rate of change bending moment is nothing but shear force. Yes, correct. See, in section XX, wherever you take section, shear force is 12. So, sometimes people will tell, from A to C it is differentiable, from B to C it is differentiable, but not at that point. It is correct actually, not wrong. If you take the ideal one, see practically, you take a point load, then correct, you can't differentiate. Now, see, this shear force is 12. That is the slope for this line. See, for this line, the slope is plus 12. Okay, now do one thing. Consider BE portion. BE portion. I will not write. You should write it. You should write. If I take this, I will remove now. See, I will remove here. If I take a section XX, you write x from here. Shear force is minus 8. No x, constant. Rate of change of shear force is 0, correct, no loading. Then bending moment equal to plus 8 into x. Plus 8 into x. Then if you differentiate bending moment with respect to x, what you get? dmx by dx equal to 8. Yes, correct. Shear force is 8. Correct. But and therefore, if I go this side, the slope of this line is minus 8. Why? Because see, here it is anti-clockwise. Don't worry about it. Here it is clockwise. Therefore, sign changed. But even then, rate of change of shear force is, rate of change of bending moment is shear force only. Sometimes people will tell rate of change of bending moment is shear force, minus will not come. If you look that side, minus will come. This I told somewhere earlier. And rate of change of bending moment is shear force. It will not come negative, it will come negative. So I told that you should sign, you bother later. It is only that slope counts, other things will be automatically covered here. Now, the most important, see, between these 2 points, very important, between these 2 points, you should write clearly here. Take a section at x, xx at x. Don't see this x now. Do not see this x. Okay. At general, anywhere between D and D, consider section xx. I will write it here now to make it pakka clear now. See, this is where you understand principle. See, I will consider DE portion. DE portion. Shear force at x, I use red color, equal to, I will clean it, lot of strains are there, stains. Okay. At x equal to, see, you write it here, don't see here. at x from here, if you take plus 12 minus minus 1000 into x. 1000 into x. Okay. Now, as per basic principle, what? D of shear force dbx by dx equal to, see here, it is, x is there now, it is linear variation minus 1000. Yes, correct. That is the intensity of load. So who told cannot be differentiated? See, it is the intensity of load. If you consider the contact length, some small distributed length, even at this point also, it is differentiable. Rate of change of shear force is intensity of load only 1000. See, minus 1000 came. So all those who tell that not differentiable, now they should learn. Then, if I want, now see, now I want where is the zero shear force. Equate this to 0. You will get 12 by 1000, that is, you get 0.012 meter x. That is the point of maximum Bm, or where shear force is 0. From here 0.012, so if I go by 0.01 meter, further by where I wrote it 0.002 meter. Very small distance. We are almost there only. Now, last important, this is the bending moment. This is where people will tell non-differentiable. See, bending moment at x, mx. This I explain, remove. I don't want this one now. That all you write later. Mx equal to, see here, plus 12 into, this is 3.99 and this is x. So here bending moment into bracket 3.99 plus x minus 1000 into x is the load into x by 2 minus 1000 into, you write 1000 into x by 2. To save the time, I will write x square by 2. You already know it. Okay. Now, parabolic variation for a very, very small length. Now, see there. If you substitute here x equal to 0.012 meter, you will get this maximum Bm of 47.952. Or when you put x equal to, see, here I write here, shear force is 0 at x equal to 0.002 meter, no, 0.012 meter. Okay, now check it. Substitute x equal to 0.012 meter. You get m maximum equal to, you substitute. Why should I substitute here? You substitute. It is, see, I'm showing calculation. 12 into 3.99 plus 0.012 minus 1000 into 0.012 square divided by 2. 47.952. 47.952. Yes, we got the answer there. See. So therefore, even here also, bending moment is maximum where shear force is 0. So the sudden change of shear force is idealization for practical, because such a small things you can't bother. 47.952 you can take as what? 48. And shear force from 12 to minus 8, it drops almost vertically, slightly slant this way. That is very, almost vertical, very, very minute shift here. That can be taken like this here. Then you can tell shear force just to left of that point is plus 12, just to right of the point is minus 8. But between those 2 points, or in between somewhere in the loaded length, there is a point of zero shear force. There should be a point of zero shear force. That is the maximum Bm. Since this contact length is very small, we take it there. So that's why we usually write up to now and next class onwards. Bm is maximum, some rare case minimum also is there, where either shear force is absolutely zero. That happen when the point comes in the UDL or UVL, or where SFD will cross the baseline. Suddenly baseline from plus to minus or minus to plus, it will change. So changing from plus to minus is not sudden, it is this way only. It has to pass through a zero shear force. This should be eye opener for all those who tell shear force there is not defined. Then the bending moment maximum where shear force is absolutely zero is not applicable for point load. No, it is applicable, but practically or idealization we write both same. Hope it is correct. Now last one, people tell Bm function is not differentiable. 1 minute, start. Now see, now most important here, therefore differentiate dmx by dx you calculate. Let me see why not differentiable. Equal to 12 into, see if I calculate here, it is 12 into, this is 0, so it will come, x will become what? X will become 1. 12 into 1 minus 1000 into 2x by 2. 2x by 2. Now, in this equation, you put x, now this is a dmx, see now, or equal to 12 minus 1000, 2 by 2 cancels, minus 1000 into x. See here, 12 minus 1000 into x is, that is shear force only. That is shear force only. Not differentiable? Very much differentiable if you really consider the loaded length. But if you replace the load, if you replace that load when the loaded length is very small, if you replace by point load, okay, then you can't differentiate. So never tell openly that differentiation is not valid, discontinuous function, singularity function, this one, that one, all. Do not tell. Understand the basic. I told you, understand the basic, how powerful it is. Your knowledge, I have not put a sign here actually, okay, no problem. Why should you bother? This is class number 100. You know the way I am teaching. See, today also I talk naturally, not in a stylish language or shouting like that. Some little slow I am talking because little late night time. I don't want to disturb the neighbors. So voice, you can increase the voice. So even today also, I talked like a natural talk, like day-to-day life. I always believe in that one. Okay, now, hope anything else? Therefore, I will tell the conclusion now for this class. Conclusion for this class is, if a point load is there, it is actually not possible to apply a load through a point. There should be some loaded length. And if the Bm is maximum, if the shear force there crosses the baseline, suddenly if you write this way, okay, no problem. Actually, it is not that way, it is like this way. There is a point of zero shear force. That is where the Bm is maximum, but that point is very, 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 very close to this point. Then you can tell at that point. So you can tell up to class up to 1 to 99, and from 101 onwards, these all I will not talk. Just for fun, sometime I will tell. Remember the special concept. So now onwards, what you will write? From next class onwards, bending moment is maximum, where shear force is either absolutely zero, maximum or minimum also is there. Sorry, either shear force is absolutely zero, or where SFD crosses the baseline. Sorry, not this way, where suddenly it will cross the baseline or change the sign. Hope the concept is clear. Go through the class completely. This note I will tell in the description. People, those who want to thoroughly understand, should go through completely. Now, there is a special concept is there. That is called brain teaser. A real brain teaser. So far, I asked this question from 39 years I am asking this question to many people. How I know the answer, I will tell you in that class. I will tell at that time. Sometimes people will tell, sir, please tell the answer. I will tell, no. Nobody told me. I only understood. So you should understand. It is not required for you. Sir, please tell, sir. People will request. I will tell, when I take YouTube class, I will ask the question for general public, everybody. Let's see who is going to give the answer, which is unanswered. As far as I am concerned, from my students or even so many people who call experts or no structural knowledge, all of them failed. They told, this I can't tell. Okay, leave it. So that is not now. See, now it is too late. What I want to do is, so this is class 100. I will put one more class immediately. Tomorrow I will put it. I will call class 100 extra part or additional part. I will put additional part of class 100 and heading will be, I don't know, brain teaser or real concept. Something I will put there. You should also, not right now because I have to raise the voice there. Some points are there where I have to raise the voice because it deserves it. I have to tell me now like that. Therefore, not stylish language, but effect will come when I insist on something in a higher voice. So I will upload tomorrow, I will prepare tomorrow, daytime I will prepare, little light problem will be there, manage it because it is a small class. Question asked, answer should come. Comment box, you have to give the answer. Okay, regarding comment, I will tell tomorrow. I will tell all my classes, in the beginning some comments used to come. All of them praising me. No. I always tell, praising me will not make me happy. I know what I am. Constructive what? Comments, like this concept is clear or doubts are the doubt. First of all, someone told me, why no comments are coming? Sir, doubt comment will come if doubt comes. When there is no doubt, why comment? Just to praise, I don't require it. I don't ask. See, sometime in online class, you can see people telling, first all of you like the session. Did I ask you once to like it? Once I asked you, like it? No, I told it should come from here. Not by asking. When you meet someone, please wish me. You don't ask someone to wish you. If a student comes, I can't tell him, hey, wish me good morning. He will tell, sir, good morning, sir. He will sometimes tell this way, good morning, sir. That is his respect, comes from his heart. You can't demand it. Okay, now, so just, see, I told I am talking freely here because now all those who are attending all the classes, you are like what? One among my group only. Even if I don't know personally, you know me. See, every day you are seeing me. So I will put class number 100, additional part, some heading I will give you, upload, maybe only 10 or 15 minutes class. But in the comment section, I will ask everybody, this is the time to show your talent. Or people who tell for this class, hey, these are all we are knowing, nothing is there. He tells so many things here. What he thinks, we know it. I will tell them, okay, you know it. Answer this question. Answer this question. If you answer it, yes, I will agree, you know it. Okay, so, okay now. Thanks for watching a long class and a lot of speech also. I told I am not good in speeches, but when I turn here, I never fumble or what, there is no confusion on me. And one more thing, by chance if there is any calculation mistake is there, correct it. Don't make an issue. Oh, I told I will derive a formula there. In the class I usually ask, shall I derive or not? Sometimes students will tell, sir, please derive, sir. But now, no time. Maybe tomorrow, next class, I will derive it. I will tell, for the class number 100, I forgot to last time, I will tell, see, all this, you can get a formula. You substitute in a formula, this loaded length, both will come. Even I know how to derive. I have not derived it because why? I will do it in front of you. I don't have to prepare for it. So here I gave all the value from first principles. Because, you know, I can find this value directly. See, without locating this point, I can give the maximum Bm. You have seen somewhere else. But tomorrow, or tomorrow means next class, I will derive this formula. Then I will tell this is a requirement for previous class for those who are serious. And then I will ask the real question. Thanks for going to the class. Now onwards, start learning concept and gain more knowledge.